Welcome to ONS Energy Talks. My name is Ingvild Meland and I'm the Program Director of the ONS Foundation. Today we will talk about hydrogen. Over time, hydrogen has come up to be an important piece or even a joker to the future energy system. Now we're seeing a new hype on hydrogen and we will discuss why this will be realized now. To help us shed light on this, we have with us Eriksen. He's the Vice President of Hydrogen in Statkraft. Statkraft being the Norwegian utility, but also Europe's largest producer of renewable energy. Ulf, it's a great pleasure to have you with us. Welcome.
Thank you. It's a pleasure to be with you as well.
I will have an interesting talk about hydrogen, and I think we'll just jump right to it. Hydrogen has come up as a favorable energy carrier due to its climate effects. Which role will you say hydrogen will have in the future of decarbonizing our societies?
Well, I think our analysis is that hydrogen will be an important part of decarbonizing the society. I think we see that it's not possible actually to reach the climate targets without the use of hydrogen. Around 70% of the global carbon emissions today comes from energy-related sources. And you have to do something about both the way that we use and produce hydrogen. And much of this can be, of course, done through electrification of new sectors and by the increased use of renewable energy in the power sector. But for other purposes, you will need to use other sources of to make the renewable change happen. And for hydrogen, this is particularly the case related to long distance transportation, where you will see that batteries cannot carry enough energy to do the task. So that happens both on land and on sea, and there you will need hydrogen-based solutions. In addition, you can see that hydrogen can replace fossil fuels for high temperature industrial processes. And I think finally we can also see that hydrogen can be used as feedstock for chemical industry and a reduction agent for steel production. And in those areas, you will not be able to use pure electricity.
So you're talking about electrification, and where electrification is difficult, hydrogen can be an important, play an important part. But in which segment, can you elaborate a little bit for international markets, which segments and which markets do you see hydrogen having the greatest potential?
Well, I think in the international markets, you can see that hydrogen will have the greatest potential within heavy transportation and within industry. I think if you look at heavy duty transportation, we already today see that in Switzerland, for instance, where they have a large taxation for heavy-duty transport, they will now implement hydrogen trucks. Hydrogen trucks from Hyundai will come on the roads in Switzerland already starting this year. So they will start this revolution. It's actually coming here and now. And we see that other large truck producers around the world are looking into this as a potential solution. Just recently, Daimler and Volvo released their plans to have a joint company to develop fuel cells and fuel cell systems for their heavy-duty trucks. And those two companies are, of course, the largest trucks producers in the world. And this development is to a large extent driven by taxation and regulation. So we see in Switzerland, as I mentioned, high road taxes, which is a strong enough driving force to make hydrogen competitive from day one, actually. And initially, we'll see also in, for instance, the EU, they have introduced regulations where you have to cut the emissions on the tailpipe of the trucks with 30% by 2030. And this will drive the developments in the EU. So all the big truck producers that wants to deliver trucks into the EU will need to have a solution to make those reduction cuts by 2030. Otherwise, they will face penalties. So regulation plays a very important role in driving these markets. You can also see the same thing happening for steel industry, where you can also have the customers demanding more environmentally friendly steel. And today, the steel production is using large and emitting large amounts of CO2 because it uses carbon for their production process. And this can be replaced by hydrogen and cutting the emissions from one of the largest emitting sectors substantially. But one of the most interesting developments, one of the areas where you can see the potential for largest emission cuts, is within the ammonia sectors. Currently, about half of the world production of hydrogen, which is emitting a lot of CO2, by the way it's produced today, is used for ammonia. And ammonia goes into fertilizer sector to 80%. And if you replace all the hydrogen in the ammonia today with the green renewable hydrogen, that would be 1,700 terawatt hours of power. So let's say 8% of the world consumption today. And you can also use it as a fuel where it has a large potential. It can be used for international shipping, where you struggle to find the other solutions for carrying enough energy. And there you could actually increase the consumption by up to 5,000 terawatt hours if you use ammonia for the entire cut that is necessary for in the international agreement.
Very interesting to hear kind of the great numbers that you're referring to, and saying that for international markets you're seeing potential within the truck segment, within the steel industry, within the ammonia production. But then if we move our eyes back to Norway, how does the picture look there? We are good at shipping, we are good at maritime industry. Elaborate a little bit about where we are in Norway.
Yeah, no, I think hydrogen poses a huge potential for Norway. I think Norway has has a very good basis to become a big player in this industry, or relatively big given our size as a country. I think our starting point is excellent. We have a leading producer of electrolyzers, which is an essential piece of equipment. We have leading producers of other equipments like storage tanks, etc. We have strong energy companies. One important part of producing hydrogen is renewable energy, and we have good availability of reasonably priced renewable power. We have industry companies focusing on this, and especially within the fertilizer and ammonia industry, as I just mentioned briefly in your previous question. And of course, as you said in your introduction, strong maritime clusters. Norway is a shipping nation and has always been a shipping nation. And in our history, we've shown that we have been in the front of adapting and developing new technologies. And I think all these sectors together can make an impact and use this opportunity that the hydrogen change will mean. So
before we go into the colors of hydrogen, I'll just wanted to ask you a question on technology, because sometimes you feel that there's a need for new technology development in order to make this development happen. Yeah. Is that really the case, or do we have the technology that we need?
I think for part of it, we have the technology available. So the technology to produce renewable hydrogen exists. We have electrolyzers, which can be used to split water into hydrogen and oxygen. These have been produced for 90 years. What is the case, of course, is that it's produced in a very small scale currently, because the use of renewable or green hydrogen is quite low. So it's mainly used from big industrial processes, and so that kind of the equipment is available. The part where there is a need to develop new equipment and new technologies, of course, in the use for various types of applications. So when you want to use it for transportation, when you want to use it in a truck or a van or larger ships, etc., then there's a need for technology development. The basis technology for generating the energy from the hydrogen, or extracting the energy from the hydrogen, exists. That's the fuel cell. So that's sort of the reverse process of generating hydrogen. So that exists, and you have cars using that today, although not big numbers, but it is increasing. So that part of the technology exists as well, but it needs to be developed, and you need to build scale. So that is one of the key challenges to build this industry. You need to build the scale that's necessary.
Interesting, because so you're saying that the market is what you lack is the market, and actually the technology that really can get the advantage to the customer. But just leave it for technology for now, and I'll jump into the colors of hydrogen, because around you have green hydrogen, you blue, gray. Could you elaborate a little bit on these three products and how you see the outlook for them going forward?
Yeah, no, I think currently there's roughly 70 million tons per year of dedicated hydrogen production, and that's mainly used in industrial processes, roughly 50-50 divided between refineries and ammonia, as I mentioned previously. So it's currently produced in large-scale plants, mainly from gas and also partly from coal. So 96% of the hydrogen that is produced today comes from that kind of process where you heat gas or coal and emit large volumes of CO2. So the total CO2 emissions from the hydrogen production today is actually almost 830 million tons of CO2 per year, and that's 15 times the Norwegian emissions. And that is because it's used, you use natural gas and coal, which emits carbon. So that production, the basis that we're starting from today, is called gray hydrogen. And if you want to produce gray hydrogen, you usually do that in big scale plants. So you produce large volumes. And of course, that's large investments associated with that. Then it's possible to reduce the emission from this process, because you can capture the CO2 emissions coming from the production process, and then store it. So through carbon capture and storage, you might be able to reduce the emissions by almost 90%. And then you change the color of it, and you will call it blue hydrogen. So blue hydrogen is based on gas, but then you do carbon capture and storage. Of course, to put in place this equipment on the large-scale production plants that exist for gray hydrogen, then that requires, of course, large-scale investments and large volumes. Then the third category that we usually refer to is green hydrogen. And then that is when you produce hydrogen from water through electrolysis. So you put, simply put, you put power on the water and you split it, and it becomes hydrogen and oxygen molecules. This is completely emission-free, and when you use renewable power to produce it. And what's interesting is that this can be produced in small volumes, and it's very modular technology. So you could set up a small plant producing for the specific purpose or the specific need you have at one specific location. And then you can start building the industry and building the hydrogen consumption in the same speed as the market develops. So we think that green hydrogen will be the starting point for developing the hydrogen industry, or the new clean hydrogen industry. And you can build a market through small volumes and small plants, and then gradually expand it. And when the volumes reach a certain size and it becomes challenging actually to fill all the demand through green hydrogen, then there is a clear room for blue hydrogen, because that would require larger volumes. So we think of it in a way that green hydrogen will build the market for the hydrogen industry, and then blue hydrogen will come and be able to supply the large volumes when those are needed. So the two technologies actually will complement each other and will reinforce each other. And if we take it back to a Norwegian context, of course, this is an advantage for Norway, because we have strong players and have good potential within both parts of that industry.
It's interesting. So you're saying we are going from green to blue, and that we need both going forward. And but now we're in the early phase of scaling up hydrogen production usage. What do you think is the most important elements that we need to really accelerate the development? Political willingness, costs, etc.
I think we have seen that there has been hype around hydrogen more or less for decades. It's come back and forth many times, and many people have believed that now is the time to start using hydrogen. So the question is, well, why do we believe that this is the right time, in contrast to the other occasions where this has been on the agenda? And I think there are two main reasons and two big changes compared to previously. One is the very much stronger focus on climate change and the strong international agenda driving measures to reduce carbon emissions. So this policy drive coming from the Paris Agreement and all the legislation that has followed will make it easier to succeed with technologies that are more costly at start, but will be more competitive in the end and will be fully emission free. And the second part is, as I mentioned previously, the green hydrogen production comes from renewable energy. So if you use renewable power to produce this, then of course the cost of renewable power is very important. Actually, around 70% of the production cost of green hydrogen is related to the power cost, so the cost of the power produced. And we have seen over the past 10 years that the cost of producing solar power in the world has dropped by 90%, and the cost of producing wind power has dropped by 70%. And these strong cost dives will drive also or make it the green hydrogen more competitive. And I think to make this change happen now, I think three basic things needs to happen from the governmental side. One thing that can be done is to have strong regulations, strong rules, strong ambitions on the reduction of carbon emissions. So doing like they've done in Oslo and set a ban more or less from 2030 onwards on fossil vehicles and etc. Doing like they said in the IMO agreement, reducing emissions from international shipping by 50% within 2050. Those kind of targets, the ones I mentioned about the EU and the truck sector, etc., those will be the first essential key to make this happen, because then the fossil technologies will not be able to compete. You can't use them. Secondly, if there is a competition towards fossil technologies, both within industry and transport, then you should make emitting CO2 costly. So having a cost for emitting CO2, either through the quota system or through a CO2 tax. And thirdly, as I mentioned, currently the scale of the hydrogen production and the production of electrolyzers and other equipment is very small. So it's actually handmade more or less today, and of course that makes it very costly. So what we've seen, the cost drops that we've seen for renewable energy and solar and wind production, that's also possible for hydrogen production. But you need to achieve scale, and the first units that you produce will be very expensive. So the government needs to also provide support, financial support for the first phase of this, to start building scale, and then eventually when the production volumes comes up, then you will get scale, and then the cost will be reduced. And we believe that the production cost for electrolyzers, for instance, will fall with 80% over the next 5 to 10 years. And I think perhaps the Norwegian electrolyzer producers are even more aggressive in their targets.
Ulf, I think this is a perfect closing for our talk. I mean, to make it happen, you need political willingness to set ambitious targets when it comes to climate. We need to put a cost on CO2, and we need to work to build scale and get the market to work. I really trust you that this will happen now, and I hope our listeners have learned more. Ulf, thank you very much, and thank you to the ONS Talks listeners. Thank you.
Thank you very much.